Okay, this video is designed to show one particular application that I found on GeoGebra. What I did was basically I was looking for a bunch of applications that dealt with linear systems. So I stumbled across this one and it's incredible. Okay, this one right here was part of a different application. This one right here really doesn't work all that well because it wasn't intended to use on this, but um, I'll show you at least some of the really cool things that can happen if you look for information and find it. Okay, I'm gonna I'm gonna basically put this system in here after I show you right now what's going on right now. Right now we have what is called a solution of a 3 by 3 matrix. It's the identity matrix equals the constant matrix. So the solution should be 2, 5, 3. Now, where this is really cool is that it shows how you can like visually represent this matrix in 3 dimensions. Okay, if you have an x value that is 2 in 3 dimensions, this green plane is like the regular Cartesian coordinate plane. Okay, that green plane is z. So as it is right now, that green is 3 above where we would call like the normal Cartesian coordinate plane. Okay, this 1 is telling us 5. This would be represented by this red plane. And this 1 is telling us 3 is represented by that plane. Now, what this basically says is that I have the location 253. This is basically the intersection of planes that are parallel to, you can't really say axes, but you can say, I guess, XY plane, XZ plane, ZY plane. Okay? Now, this is the ability to do linear transformations on any of these systems. Okay, I don't even want to get into that. That math is probably beyond most of the people who would be watching this video. What I want to show you right now is it shows the solution in 3D on those planes. Now, the nice thing is you can in fact move that picture and rotate it so you can see it in 3D. This is from a free application that has a Creative Commons license. That is just amazing. Now, the thing that's really amazing is that it itself has examples built into it. So if I click on example 1 or example 2, it gives me a different system. It gives me this system. And I can toggle on or off the solution. Now, it's hard to see in that particular like viewpoint, so you kind of have to move it around. The red, blue, and green plane really intersect there, and I'm going to click on that button, and I can show that that system is there. It labels it on the figure. It shows you in a way, like honestly, all I had to do is toggle those, and I get those planes. That's incredible. Well, that was just based off the system that was given by itself. Okay, now what would this question mark thing be referred to? Okay, well, if you look at this question mark thing, it shows you a system that doesn't have a single solution but has infinitely many based off of this line. Now, I could not do this in class. I couldn't have talked about those 3 systems in class that quickly, and I certainly couldn't have toggled the slider or even caused that rotation to happen, which I did accidentally. That's incredible. Okay, but I'm going to go back to the first example. We have this. Now, what I would like to show you, other than like right here where you can show toggling and additional planes being done, I mean, that's incredible. The fact that you really have any linear combination of those planes intersecting at that one particular point. I wish there was, and you can toggle those other systems off to show you that when you modify one system, you get another system. That's incredible all by itself. I mean, I couldn't do that in like 10 hours drawing on the board. Okay, I'm going to turn those on and I'm going to turn these off. Okay, what is amazing is that I can like use slider documents to basically cause changes in whatever linear system I have, And since these are sliders, I tried to put a couple of these in to see if they can have the same impact. So the first one is 2113. 2113. See the dynamic changes there? See how the solution changed? See how that moved? That's just incredible. -1221. -1, 2, 2, not 2, -2, but 2, 2. And then we're going to go back to 1. Okay, again, a solution. It's incredible. It's dynamically changing solutions with each toggle. 1, -1, -3, -6. 1, -1, what was the other numbers? -3, -6. All right, again, I couldn't have done this in an hour. I mean, I just went through like 4 linear systems with 3 variables in like, less than 10 minutes. That in itself, just for what I've done, is worthwhile. I'm going to give that to the Algebra 2 teachers in my building and say, you're welcome. And I mean, I can't do better than that. The TI Inspire even forces you to solve for the variable z, and you can't represent like this changing of like your matrix. Now, what I will do there is, if you take a look at this, it allows you to do that, and then I'm going to replace equations in there. So it's basically showing you along the way that when you do matrix math, you could eliminate and change your linear systems. There's infinitely many linear systems that have the same solution. Okay, which is incredible. Okay, now I think that I really want to change this one to say -10. And then the 1 and 2, we do that, and I replace those. How about we make it, this one's 10. Alright, we'll go 1 and 1 to show you what happens with the bottom 2. Okay, if I multiply this one by 1 and this by 1 and add them together, my x term should drop off of one of them. And it does. And I'm going to replace these equations. And notice how this no longer has an x term. It's incredible. All right, well, that's basically what I wanted to show you. I mean, that was a really cool application. Thank you for watching my video.